Chapter 5, Section 3, Combining Radicals and Simplifying Radicals that Contain Variables. So when we talk about combining radicals, what we're talking about is kind of like combining like terms. For example, in basic algebra, you know that if you have 3x plus 5x, these are like terms and you can put them together so you have 8x. Well, when you talk about combining radicals, it's the same thing. You must have like radicals, basically like terms, which means that you have to have the same index and the same radicand. So to put things together, combining means addition and subtraction. To add and subtract radicals, you must have like radicals, which means the same index and the same radicand. So, here are your steps. Step number 1, simplify each radical if possible, and then combine like radicals only. So let's look at this example. In this example, none of these radicals are alike because none of the radicands are the same. So what we need to do is we need to see if we can simplify each one of these radicals first. So for the first one, we have 3 square roots of 45. I know that 45, and again that says 3 times the square root of 45, but 45 will break down into 9 times 5, and then the square root of 20 will break down into 4 times 5, and the square root of 18, or square root of 80 rather, will break down into 16 times 5. So if we keep simplifying, we're going to have 3 times the square root of 9 is 3, and leave the square root of 5 under because you can't take it without getting a decimal, minus 2 times 2, square root of 4 is 2, and you can't take the square root of 5, minus the square root of 16 is 4, and you can't take the square root of 5. So finish the multiplication. We have 9 times the square root of 5 minus 4 times the square root of 5 minus 4 times the square root of 5. So now we can start combining these radicals, because look, all of the radicals are like, they all have the same radicand. And so what we're going to do is we're going to take these coefficients, 9, -4, and -4, and put those together. And when we do that, we have 9 minus 4, which is going to be 5, minus 4 again, which is going to be 1. So we're going to have 1 square roots of 5, and you don't have to write the 1 unless you just want to. So that's combining radicals. What happens if we have fractions? Well, a couple of things when you're adding and subtracting fractions. You know that you have to have a common denominator. And when you're dealing with radicals, not only do you have to have a common denominator, but you also have to have a common radical, or like terms. So what I would like to do initially is simplify these radicals. So 24 is going to break down into 4 times 6, and then 54 is going to break down into 9 times 6, and then the square root of 96 will break down into 16 and 6. So if we keep going with this, keep simplifying, we're going to have 3 times 2 square root of 6 minus 2 times 3 square root of 6 over 5 plus 4 square root of 6 over 4. And so now, finish this multiplication, we'll have 6 square root of 6 minus 6 square root of 6 plus 4 square root of 6. And then what we're going to do now is we're going to combine all these like radicals. And we do have fractions, so just remember to add fractions, add or subtract fractions, you have to have a common denominator. So, and that should be a 4, sorry. And our common denominator I think is going to be 20. So I need to multiply here by 20 over 20. For this one to go to 20, I need to multiply by 4 over 4. And for this one to go to 20, I need to multiply by 5 over 5. So I'm going to have 20 times 6. So we're going to have 120 square root of 6 over 20 minus 24 square root of 6 over 20 plus 20 square root of 6 over 4 over 20. So now what I'm going to do is I'm going to combine all of these numerator whole numbers. So we're going to have 120 minus 24 plus 20. And we're going to get 116 square root of 6 over 20. So we need to reduce 116 and 20. Let's see. And I think that's going to be 29 square root of 6 over 5. Okay, so what about cubes? Cubes is going to be the same thing. You're going to have to simplify and look for like radicals. So for the first one, the cube root of 24, cube root of 24 will break down into 8 times 3. You can't do anything with the cube root of 3, so we're just going to leave it as is. And then the cube root of 81 is going to break down into 27 times 3. And so we're going to have 4 times the cube root of 8 is 2, and then we have the cube root of 3 left under, plus 3 times the cube root of 3, we can't do anything there, minus 2 times the cube root of 27 is 3 cube roots of 3. Finish the multiplication, so we'll have 8 cube roots of 3 plus 3 cube roots of 3 minus 6 cube roots of 3. Now all of our radicals are the same, so we are just going to put together these coefficients. So we're going to have 8 plus 3 minus 6 is going to give us 5. So we're going to have 5 cube roots of 3. Alright, so what about if we have variables underneath the radical? Well, we're going to simplify our numbers the same way that we've always simplified our numbers. 52, think of a perfect square that will go into 52. And it's going to have to be the biggest one. And I'm coming up with 4 and 13, so 4 times 13. Now, as far as the variables are concerned, there's 2 ways that you can go about this, and how you go about this is completely and totally up to you. The way that I prefer is I'm going to take my index and I'm going to divide each one of these powers, because if you think about it, x to the 4th is the same thing as x times x times x times x. Well, you're going to have a x squared times x squared. So, and then x squared times x squared, of course, is x to the 4th. So if you take the square root of x to the 4th, you're going to get x squared. And basically what we're doing is we're just dividing that power by 2. So what I like to do when I take the square root of variables is I just like to divide the powers by the index. So the square root of 4 here, the square root of 4 is 2, so it's going to come out. And then the square root of x to the 4th, this one, I can divide 4 by 2 evenly and get 2, so I'm going to have x squared. And then when I divide the square y to the 3rd divided by 2, so in other words, if I do 3 divided by 2, 2 will go into 3 one time, so that means I bring 1 y out, but I'm going to have 1 left over underneath. So underneath I'm going to have 13y. So what's going on? Well, another way that you can do this, and it's however you can keep it straight, is up to you, or however you learned it initially, that's completely totally up to you. So x to the 4th is 4x's multiplied together, and y to the 3rd is 3y's multiplied together. Well, your index is 2. So for your 4, you just take the square root and bring that 2 out. And then the 13 has to stay under because you can't take the square root of that. But if you have an index of 2, what you're doing is you're looking for pairs, because x times x and x times x. So we made two pairs. So the square root of x times x is going to be x, and the square root of x times x is going to be x. When you multiply those together, you get x squared. Here's another pair, so we're only going to have one y that will come out, and then the other one has to stay under. So, like I said, to me it's just easier to divide my powers by my index, and then if I have a remainder, that's how many stays under. However many times it will go into it, that's how many comes out. So for example, for your x's, 2 will go into 4 2 whole times with nothing left over. So I know that x squared comes out. But whichever one you want to use, that's completely and totally up to you, or however you learned how to do it. So for this one, we have 2/3. And then 45 will break down into 9 times 5. So the square root of 9 is going to be 3, so that's going to come out. Can't take the square root of 5, so that has to stay under. Can't take the square root of just x to the first, because 2 won't go into 1. But the y to the third, 2 will go into 3 one time, so I know I have 1y with 1 left over, so 1 stays under. So do the multiplication, 3's cancel each other out, and you're going to get 2y square root of 5xy. So what if we do addition and subtraction with radicals that have variables in them? Same thing. We're going to simplify our radicals where we can. So square root of 12x is going to break down into 4 times 3 times x. Square root of 27 is going to break down into 9 times 3 times x. And 48 has a couple of perfect squares, but we want the biggest one. So that's going to be 16, so we're going to have 16 times 3 times x. Take the square root where you can. The square root of 4 is going to be 2, so it's going to come out, and you can't take the square root of 3 or just 1x. Square root of 9 is going to be 3, so that's going to leave me with 3x underneath. And the square root of 16 is 4, and the 3x stays underneath. Let's finish our multiplication. So we have negative 4 square root of 3x plus 9 square roots of 3x minus 20 square roots of 3x. Now we have all like radicals, and just to give you a heads up, every time you simplify these radicals, you won't always get like radicals. So don't expect all of them to be like radicals like these turned out. If they don't, then you just can't put them together. But if they do, then you can put them together. So let's do negative 4 plus 9, which is 5, minus 20, which is going to give us a negative 15 square root of 3x. So let's look at this one. Remember how we simplified radicands that are fractions, in other words, a fraction underneath a radical? First thing we want to do is see if they will reduce, and 5 and 12 will not reduce, so that will not reduce. So what we're going to do is we're going to have the square root of 5 over the square root of 12x to the third. So the square root of 5, again, you can't do anything with that, but the square root of 12 is going to go into 4 times 3, and then of course you have your x to the third that you have to deal with. So we're just simplifying this. So we have the square root of 5 over the square root of 4 is 2. Can't do anything with that 3, but x to the third, you can bring out an x. Remember, the index is 2, so 2 will go into 3 one time, so we'll bring 1x out, and there's 1 left over. So now we've taken care of the fraction underneath the radical, but now we've got to get this square root of 3x out from the denominator. So we're going to multiply the top and the bottom by something that's going to get us give us perfect squares. So to make the 3 go to a perfect square, I'm going to multiply by 3, because 3 times 3 is 9, so I can take the square root of that. And then if I multiply x times x, that's going to give me x squared, so I can take the square root of that as well. So top and bottom. So what I'm going to have now is I'm going to have square root of 5 times the square root of 3x is the square root of 15 x. Can't do anything with the 2x because it's a whole number, but the square root of 3x times the square root of 3x is the square root of 9x squared. So now what's going to happen is we have the square root of 15x over 2x times the square root of 9x squared is 3x. So we're going to have the square root of 15x over 6x squared. And you can't reduce anything because remember, one's a radical, one's a whole number, so you can't reduce any of that. So let's try again. Split these up. Simplify where you can. I know this x to the third will simplify, so I'm going to bring an x out. And I have 1 left over underneath. Again, 2 will go into 3 one time with 1 left over the square root of 7. Now I need to multiply the square root of 7 by something that's going to give me a perfect square. So if I multiply by square root of 7, I'm going to get the square root of 49. That's a perfect square. So top and bottom. So we're going to have x times the square root of 21x over 7 times 7, which is 49. So if we keep going, we're going to have x over the square root of 21x over 7. And that will not reduce again because this is a radical. This is practically a decimal, actually, and this is a whole number, so those will not reduce. Alright, last one. Like we talked about in the previous section, you can reduce radicals with radicals. So in other words, this 2 will go into itself 1 time, and 2 will go into 8 4 times. As will the variables. This x will go into this x squared, leaving you with x. So let's look and see what we have left. We have the square root of 4x over the square root of 1. And so the square root of 4x is 2 square root of x, and the square root of 1 is just 1, and we just really don't need that. So you get 2 square roots of x. So what I would like you to do is I would like you to attempt these problems. If you have any questions, just bring them into class and we'll